So students, in last lecture we have seen what is earthing, right? So we will just do a quick revision. So what we have seen is why earthing is provided. So we will see, so this is phase and neutral, right? So what happens whenever we give this phase and neutral, our circuit gets completed. Then what will happen? Current will flow through this circuit. Now we provide here insulation. So this is the layer of insulation, right? So this is the layer of insulation. So what is this insulation? So insulation has high resistance. So resistance means what? Resistance means opposition to flow of current. So what will happen? There will be no current flowing from this insulation, right? So there will be no current flowing. The current will only flow from this conducting part, right? Now we will cover this with metallic part, right? This is the metallic part. So metallic part, that means it is conducting material, the current can flow, but there is insulation here, right? So this is insulation, so current will only flow from this. Current will not come to this metallic part until and unless our insulation is good. But by any fault or any damage may get happen to our insulation, by heating also this insulation may get damaged, right? So whenever this insulation will get damaged, what will happen? This live part, the current will come in contact with this metallic part. Then what will happen? The current will start flowing through this metallic part also, right? Now in last lecture I have gave you one example of iron. So whenever we touch the metallic part, what will happen? The current, or we will get shock, right? To avoid this happening, to protect the human or the person from this, what we do? We provide earthing to this metallic part. So whenever the current will flow from this metallic part, what will happen? This current will flow and it will come and go to this earth. So earth is basically at zero potential. That means this current will directly go to this earth. So whenever we touch, what will happen? We will not get any shock. But if this earthing is not provided, then what will happen? All the current will flow from human body, right? But now here we are providing earthing. So all the current will flow from this earth and it will get earth. Now if we will touch this, we will not get shock. So earthing is provided. So there are some rules. So these are called Indian electricity rules for earthing. So what are the Indian electricity rules? In your textbook there are many rules, but I have chosen some important rules, right? So you have to do this rules only if they ask in exam. So what are the Indian electricity rules? So Indian electricity rules means what? We have to follow these rules. We have to. It is must that we should follow these rules. So the first rule, what is the first rule? So the first rule says earthing electrodes or plate should be installed at least 1.5 meter away from the building, right? So now consider this is our building. So this is our building. Okay. Now there must be earthing provided. So earthing is provided underneath the ground. So this is our building. So this distance must be 1.5 meters away from building. So we have to do earthing here. We have to place the electrode here. The distance must be 1.5 meter away from our building. So it must not be in this area. In this area, it should be here, 1.5 meter away from our building. So what it says, the earthing electrode or plate should be installed at least 1.5 meter away from the building. So this is the first. So it is easy, right? So just understand that our earthing should be provided 1.5 meter away from the building. What is a second? For plate or pipe earthing, material must be used same. So we have discussed in this plate and pipe earthing. So whenever we use a GI pipe or GI plate, all the material must be of same. That means it must be of GI, that is galvanized iron. So whenever we use copper, all the material, that means nut, bolt, everything, washer, it must be of that same material. So now consider we have used the plate earthing, that we have used galvanized plate. Then what we have to do, we have to take all the material, that means nuts, bolts, everything of galvanized iron. This is the second point. Now third point, earthing electrode should be placed vertical to the direction in earth. So we have to place the electrode, that is a plate. So now consider the plate earthing. So we have, this is our plate, right? So this is our plate. So we have to not place this plate in this direction. We have to place the plate in vertical direction only. So what happens? So whenever we place this plate in vertical, so these are the layers, right? So these are the layers of earth. So more layers will come in contact with this, right? So whenever there is a weight here, our soil is wet here, then what will happen? Resistance is low, right? So when this, consider this portion or this layer is wet, this is dry, then what will happen? Somehow our plate is coming in contact with wet part, right? Now whenever I keep our plate in horizontal position, it is not coming in weight, it is not coming in contact with this weight material, right? So whenever we place in vertical, it will come in contact with at least some part of wet material, right? So we have to just remember, earthing electrode should be placed vertical in direction, not horizontal. Size of earth wire should not be less than half of the phase conductor. So it is very simple sentence. So it is saying that size of earth wire, so whatever our earth wire will be, so the size should not be less than the phase conductor. So the size of earth wire should not be less than half of the phase conductor. Now we'll see the next point, that is fifth. Earth wire should be taken through galvanized pipe to avoid the damage of earth. Now this is where we are providing earthing, right? So our wire, that wire will come here, from here, and it will go to the building, right? Now whenever it is under the ground, so it must be in galvanized pipe, right? So this must be in galvanized pipe. Why? Because whenever there will be many works on the ground, right? There will be rocks, stones will be there, so our wire will get damaged, right? But whenever it is in pipe, it will not get damaged, right? So we have to place our wire in galvanized pipe. Now consider this example. So this is our pen and the refill is inside. Now consider this as galvanized pipe and this is our wire. So whenever I place this wire in this galvanized pipe, and whatever there will be the damage, it will be to the pipe, but our wire is safe, right? But when this wire is like this only, then the wire will get damaged directly. So we have to place the wire in galvanized pipe to avoid the damage of the earth. Now next point is, sixth point is, alternate salt and coal layer must be used for effective earthing. So we have already seen what we have to do. We have to provide the alternate layer of charcoal and salt. Why? Because this provides the effective earthing. That means they reduce the resistance. Resistance is reduced, so current will flow easily. So whenever we provide the alternate layer of salt and coal, effective earthing is done. Now seventh point is, earth wire should be linked and connected to the main board by looping method. Main earth wire should be connected to earth electrode only. Now what is the meaning of this sentence? So it is saying earth wire should be linked and connected to the main board. That means whatever the wire will come from this terminal, it should be linked to the one. Now what is meant by looping? So consider this is our switch, right? So whenever it will come to this, it will go from this point only to the next point. Now from this point it will get to the next point. From this point it will go to the next point. So this is called looping, right? So this is called looping. Earth wire should be linked and connected to the main board. So whatever our main board is, we have to connect or we have to give that earth wire to this main board, and from this main board we have to loop this wire. That means we have to take this wire from this to another next point, and from this point we have to take it to the next point, right? Now what is the second? Main earth wire should be connected to the earth electrode only. Now consider this is building, right? There are this many houses here. So every house there will go one new earth wire, right? So we have to connect that all earth wire in single earth wire and then give to this. Then we have to give to this earth electrode. We have to not give all separate wires here. We have to make this separate wires here and then give single to this earth electrode, right? So this is the point. Now this earth 8th point is earthing terminal are clean and filed for proper conductor before connecting of earthing to the system. So before doing this earthing system, what we have to do? We have to clean the terminals. Earthing terminals must be clean. And now 9th one is bitumen compound is used to avoid corrosion as they are water and acid resistance. Now, as we all know, this earthing electrode or whatever earthing is done, it is underneath, right, below the earth. So we have to avoid the corrosion. What does it mean by corrosion? Guns, right? We have to avoid the corrosion. So what we do? We use a bitumen compound. So this bitumen compound, it is water resistance. That means the water, it will not allow water to come in its contact, right? So our whatever the earthing system is avoided from corrosion. So the sentence is a bitumen compound is used to avoid corrosion. Now we will see electric shock. So effect of electric shock on human body. So what happens when the human body gets electric shock? So first point is overheating or burning of body. Whenever the human body gets shock, what happens? The body burns, right? So the human body burns. Overheating happens. Overheating or burning of body. Stop the breathing caused by blocking in the nervous system. So our breathing is stopped. We cannot breathe when there is severe shock, right? Third one is damage the heart to small pieces. Our heart gets damaged. When we get severe shock, what happens? Our heart gets damaged into small pieces. There is a serious danger, or whenever there is serious danger of death in the above effects of electric shock. So whenever we get shock, there are many chances that one person may lose his life. And this third one, so whenever the heart or there is damage to heart, the rescue of this person is very that means the person, there are no chances that person can live, right? So this shock, electric shock, is very dangerous. Now the seriousness of electric shock depends upon the factors. That means on which factors this shock depends. That means the shock may be severe, shock may be less severe, right? So we have to classify that. So the current strength. So the electric shock depends upon first is current strength, right? So the current strength, that means strength means what? The effect. right? If the current strength is more is the danger, right? If the current is more, then the obviously our human body will get more shock. So it depends upon current strength. More the strength, current strength, more is the danger. So the current above 30 milliampere when passes through the chest, so whenever the 30 milliampere will pass through the human body, through the chest, the breathing is stopped, right? So this is the first point. Second point is body resistance. As we discussed earlier, the human body or the wet dry body has has high resistance, right? But whenever the body gets wet, whenever it comes in contact with water, the resistance becomes low. That means the opposition is low. So the current will flow from the human body is high. So what they are given here, body resistance, that means wet body has less resistance. As I said, wet body has less resistance, and seriousness of shock is more. So whenever body is wet, resistance is low resistance. What is meant by low resistance? There will be the less opposition to flow of current. So the current will be more, right? Now frequency of current. As we have seen in AC and DC chapter, AC has less, that means AC has less severeness to shock than DC. DC has a more severe, from DC we can get a more severe shock. Shock is more dangerous when frequency is low. So DC has 0 frequency and AC has a 50 Hz frequency. So DC, depending upon frequency of current, so less the frequency, more is the shock. So DC will get more shock as compared to AC, right? The seriousness of electric shock depends upon the path of current through the body. So it depends upon the path of current flowing in the human body. If it damages the heart, then there is no chance of that human to live, right? So this is about the electric shock. Now we will see what if the human gets electric shock, how we can help that human, to rescue that human, what we can do. So if person is stuck in live wire, that means if he gets shock, then what is the first step that we have to do is, we have to switch off the supply. Supply must be switched off. We have to switch off the supply immediately. If this is not possible, so whenever if the person is getting shock, then first step is to switch off the supply. So whenever we turn off, there will be no shock flowing forward. But if it is not possible to switch off the supply, then what we have to do? We have to break the contact between the person and that live part. Now consider this is the equipment and the current is flowing. Whenever person will touch this, what will happen? Current will flow from the human, right? So what we have to do? We have to switch off the supply, but if it is not possible, then we have to break this contact. So how we can break this contact? We have to take the dry wood stick. So what we have to do? We have to take one dry wood stick and pull the person behind, right? If there is any fire created, then what we have to do? We have to extinguish that fire from the clothes of the person. Now third point is, if person is not breathing, so whenever we get shock, our breathing stops, right? So whenever the breathing stops, what we have to do? We have to give that person artificial breathing, right? First, what we have to do? We have to lay down this person on the floor and we have to give the artificial breathing. So whenever we see that person is getting back, or it is, if the person is recovers, so we have to not stop the artificial breathing. what will happen if we stop? The man will go again in unconscious state. So we have to give the artificial breathing, so for the long time. So this is about it. So we have to provide the artificial breathing for certain time. So this is about it, how to cure from electric shock. Now we will see insulating substances. So as you can see on the screen, the chart. So here what it is? The first is classes of insulation. So what is insulation? Insulation is the material which will oppose the electric current to flowing from it. So class of insulation, they are classified depending upon their temperature range. So in next you can see the temperature range is given, right? So the temperature range is given from 90 to 225. So depending upon that temperature range, they are classified, right? So in class Y, the temperature range is 90 degrees and the materials are PVC, fiber, cotton, cloth, silk. Now in class A, the temperature is 105 degrees. So these are the materials, right? They have given the materials which come under the class A. So materials like resin, fibrous materials come in the A, class A insulation. Now class C insulation, temperature is 120 degree. Plastic and enamel come in this grade. Now class B, the temperature is 130 degree. Asbestos, mica and fiber come in this class B. Now class C type of insulation, temperature range is 155 degrees Celsius. Now what the material comes is varnish. Now class H, temperature range is 180 degrees Celsius. Composition, composite materials on fiber and mica. Now class C, the temperature range is 225 degrees Celsius and what the material comes is high grade mica and ceramics. So you have to just learn this